AP Calculus AB, Section 1 Exam Review, Question 5, Implicit Differentiation. If 3x squared plus 2xy plus y squared equals 2, then the value of dy dx at x equals 1 is a, negative 2, b, 0, c, 2, d, 4, or e, not defined. So what we're going to do is find the derivative using implicit differentiation. Thus, d dx of 3x squared plus 2xy plus y squared is equivalent to d dx of 2. So in implicit differentiation, you differentiate on both sides of the equal sign. Now we're going to differentiate the sum term by term and factor out constants. So 3 times d dx of x squared plus 2 times d dx of xy plus d dx of y squared. Oh, and notice that we're differentiating with respect to x rather than y. It doesn't really matter which one you choose, but the convention is usually to choose x. All right, is equivalent to d dx of 2. Now we're going to use the power rule. So d dx of x to the n, and we have x to the n terms right here. Where else? We have it right here as well. Is equivalent to n times x to the n minus 1, where n equals 2, as we can see here, because we're dealing with the x term, x squared term that is, and d dx of x squared is equivalent to 2x. So that's what gets substituted right here, okay? But we took the 2 out, like we separated it. Now we're going to simplify the expression. Actually, no, we took the 2x out right here. I'm so sorry. And the expression is going to be 6x. This is what this becomes. Our 3 times the derivative of x squared plus 2 times d dx of xy plus d dx of y squared is equivalent to d dx of 2. Now using the product rule again, d dx of uv equals v times du dx plus u times dv dx. Just take this step by step, okay? So we're going to allow u to be equivalent to x and v to be equivalent to y. Therefore, we get 6x plus d dx of y squared plus 2 times x d dx of y plus d dx, okay, times x y is equivalent to d dx of 2. Now that we've gone through the product rule, the derivative of y is y prime, so we substitute that here. And I'm just going to let you realize the entire expression. So again, we just rewrite 6x plus d dx of y squared plus 2 times y prime x times x plus d dx times y is equivalent to d dx of 2. Now, okay, more complication, using the chain rule, which states that d dx of y squared is equivalent to du squared du times du dx, where u is equivalent to y. That's what we substituted right here. And du of y squared is going to be equivalent to 2. So this is going to be equivalent to 2, okay? So now we have that 6x, this now became this, is equivalent to 2 times d dx of y times y plus 2 times d dx times of x times y plus x times y prime x is equivalent to d dx of 2. The derivative again of y is y prime, so we're going to evaluate that once more. So dy dx now becomes y prime. Okay. And you're going to add that to 2 times d dx of x multiplied by y plus x times y prime x is equivalent to d dx of 2. Now, the derivative of x is going to be 1. So we just substitute that. So d dx of x just became x because the exponent here is 1 or n. So you're going to bring that down. And x to the 0 is just going to be 1. So 1 times 1 is 1. And we get that 6x plus 2y y prime x is equivalent to 2 times 1y plus x prime x times y prime of x is equivalent to d dx. The derivative of 2 is going to be 0, so we just plug that in. I won't really read the whole expression again. I think you get the point. Now we're going to expand the left-hand side. So we have that 6x plus 2y is equivalent to 2xy prime times x plus 2y y prime times x is equivalent to 0. Now we're going to subtract 6x plus 2y from both sides, and we get that 2xy prime times x is equivalent to 2y prime times x, which is all equivalent to negative 6x minus 2y. Now we're going to collect the left-hand side in terms of y prime of x. Therefore, we factored out a 2x plus 2y, and we get that you have y prime of x by itself is equivalent to negative 6x minus 2y. Now what you're going to do last is divide both sides by 2x plus 2y to isolate y prime of x by itself. And this is equivalent to negative 6x minus 2y over 2x plus 2y. So the original question wants to know what's the value of dy dx when x is equivalent to 1, or what's the value of y prime when x is equivalent to 1. So we know that x is equivalent to 1 in this scenario. So what we want to do now is find the value of y. And in order to do that, we plug 1 into the original expression. So we get that 3 plus 2y plus y squared is equivalent to 2. Now what you can do is carry 2 over to the left-hand side, and you can just rewrite and flip everything, so you get that 0. Yeah, so if 3x squared plus 2xy plus y squared equals 2, then the value of dy dx or y prime at x equals 1 is not defined. Okay,